Good. All right, so now let's look at this concept of closed interval discontinuity or continuity. Closed interval continuity. Okay, so we have continuity at a point. We have open interval continuity. So now we're going to add the endpoint. So then the question is, what is closed interval continuity? So a function is continuous on a closed interval from A to B if it is continuous on the open interval from A to B, and if, so then we need two things. I mean, you kind of have to imagine what's going on here. You know, we have some function. I'll draw a little one right here. That's going from here to here, let's say. Now in open interval continuity, these were both circles. So we just say as long as it's continuous on every point, we're good. But in closed interval continuity, we have these endpoints, and we can't say that this point is continuous because we don't have a limit here. We don't have this right-hand side. So we're going to have to use the concept of left endpoint and right endpoint continuity. So the first one is going to be the limit as x approaches a. Let's see, this would be a from the right hand side of f of x equals f of a. So this would be a right here. And if the right hand limit equals f of a, then it is continuous, and we call that continuous at a left endpoint. And then this is b. b would be, or the side b, point b, would be the limit as x approaches b from the left side. So we have to come from the left side of f of x equals f of b. And this is a continuous at a right endpoint. So in order to be continuous on a closed interval, then you have to be continuous, you have to have these left and right hand limit continuity kind of things, left and right endpoint continuities, so that we can say now that this is continuous on the closed interval. So let's look at a function that works for. So quick example here. Let's say we have y equals the square root of 2 minus x squared. So there's our circle again. It has a radius of the square root of 2. So let's go ahead and draw that out. So this would be a negative square root of 2, this would be the square root of 2, and this would be the square root of 2. Half a circle. The upper half of the circle. And so we can say that this is continuous on the closed interval, because of course it is continuous on the open interval from negative square root of 2 to square root of 2. And the left endpoint is continuous because as we take the limit, here let's do the right endpoint. So as we take the limit, so first of all, f of the square root of 2 equals 0. And then the limit as we as x approaches the square root of 2 from the left-hand side of f of x also equals 0. So because the limit, the left-hand limit equals the function at the square root of 2, we can say it is continuous at the right endpoint. Then you can do the same thing for the left endpoint. So we can write y equals the square root of 2 minus x squared is continuous on the closed interval from the negative square root of 2 to the square root of 2.